Hello, saver. Whether you're saving for that trip to the tropics or saving for an emergency, now is the time to take advantage of Wells Fargo's savings options. Wells Fargo offers savings accounts that can help you save towards your goals. So, what are you saving for? Visit a Wells Fargo branch or wellsfargo.com/save to open a savings account today.
Wells Fargo Bank, N.A., member FDIC.
This is SpaceTime, Series 23, Episode 44, for broadcast on the 11th of May, 2020. Coming up on SpaceTime, discovery of the nearest black hole to Earth, how galaxies grew so big so early, and the asteroid out of nowhere. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Astronomers have discovered the nearest black hole to Earth, located just 1,120 light-years away. A report in the journal Astronomy and Astrophysics claims the black hole was detected when astronomers studying HR 6819, also known as QV Telescopy, a binary star system in the southern constellation of Telescopium, noticed signs of a third invisible star about 4 times the mass of the Sun, which was affecting the orbits of the other 2 stars in the system. So, instead of a binary star system, it would appear HR 6819 must be a triple star system. And because astronomers could find absolutely nothing where this 4 solar mass object should be, it's got to be a black hole. Not only is this the nearest black hole to Earth, it's also the only one whose star system can be seen from Earth on a dark, clear night without the need of binoculars or a telescope, but simply with the unaided eye. The authors made the discovery using the European Southern Observatory's 2.2-metre telescope in Chile. The study's lead author, Thomas Ravinius from the European Southern Observatory, says the system could just be the tip of the iceberg, as many more similar black holes are likely to be out there. Ravinius and colleagues were studying binary star systems, and as they analysed the data from the 2 stars in HR 6819, they realised that one of the visible stars was orbiting a third invisible body every 40 Earth days. The authors already knew that the star orbiting with the black hole was a massive spectral type E blue variable star, some 6.3 times the mass of the Sun, almost 4 times the Sun's radius, and some 450 times as luminous. This hot young blue star has a surface temperature of more than 20,000 Kelvin and is estimated to be around 50,000 years old, just a baby by stellar standards. The other visible star in the system is another spectral type B blue star, and it's in a wide yet-to-be-determined orbit around the inner pair. Astronomers have only discovered a few dozen or so black holes in our galaxy so far, although millions more are expected to be out there. Virtually all those that have been found were detected as powerful X-ray sources because they were feeding on infalling material. You see, as matter falls into a black hole, it first forms an accretion disk where it's heated up through friction, releasing X-rays, before falling beyond a point of no return called the event horizon, beyond which it falls forever towards the black hole singularity, a place where science's understanding of the laws of physics break down. The discovery of a silent invisible black hole in HR 6819 provides astronomers with clues about where many other hidden black holes could be found, and knowing what to look for should be putting astronomers in a better position to find them. In fact, already astronomers believe this discovery could shine some light on a second system known as BL1, which could also be a triple star system with a black hole. BL1's a bit further away from Earth, but it's still close in astronomical terms, and so it's likely to be a key target for future study. By finding and studying these systems, astronomers can learn more about the formation and evolution of stellar mass black holes, which begin their lives as core collapse supernova explosions of some of the universe's most massive stars, or through the merger of even more exotic objects called neutron stars. This is SpaceTime. Still to come, how galaxies grew so big so early, and astronomers get a shock when an asteroid the size of a van suddenly swoops out of the darkness of space, streaking just 1,200 kilometres above satellites. All that and more still to come on SpaceTime. One of the big questions in cosmology is how galaxies manage to grow so big so early. Well, a new study suggests that early galaxies began growing big through their own internal gas reserves before they began consuming mass from other smaller nearby galaxies through galactic cannibalism. The findings, reported in the Astrophysical Journal, provides another step in the path to understanding how some galaxies could grow to enormous sizes at such an early phase in the evolution of the universe. The study's lead author, Anshu Gupta from the University of New South Wales, says the question of exactly how massive galaxies attain their size has been poorly understood, not least because they swell over billions of years. Galaxies like the Milky Way are thought to have started forming well over 12 billion years ago, from the accumulation of ancient stars, gas and dust. In fact, there are stars in the Milky Way which have already been dated to well over 12 billion years. Gupta and colleagues reached their findings by combining data from MOSEL, the Multi-Object Spectroscopic Emission Line Survey, together with a cosmological modelling program running on some of the world's largest supercomputers. The authors looked at how gases were moving inside galaxies. By analysing how gases move, it was possible to discover the proportion of stars made internally within galaxies and the proportion effectively cannibalised from elsewhere. They found that galaxies located around 10 billion light-years away tended to have a significant proportion of their stars moving in a range of different directions. And that suggests that these stars were dragged into their host galaxies through gravitational tidal perturbations from other galaxies, through the process of galactic cannibalism, where big galaxies consume smaller satellite galaxies. But at the same time, they found that galaxies 11 billion light-years away were showing far less disorder, suggesting that they were made up of stars that were formed from within the galaxy itself. See, because light takes time to travel through the universe, galaxies further away from the Milky Way are actually being seen at an earlier point in their existence. Gupta says the big question's always been how did these galaxies get so big so quickly? And she says the modelling clearly shows that younger galaxies have simply had less time to merge with other ones.
So my research is about understanding how galaxies, like our own Milky Way, they form and evolve. And in this particular project, what I'm looking at are galaxies which are Milky Way size or a little bit bigger, but they are about 11 billion years away from us. Basically, these galaxies existed when the universe was only 2 billion years old. Which might sound quite large, but for our universe, our universe was just a teenager at that time. So what we want to do is we want to look at these galaxies which formed when universe was so young, and we want to know how these galaxies became so big and so large when the universe was so young. And we want to know where did the stars in these galaxies they formed? Did they form inside the galaxies? Or these stars came from other galaxies, etc.
There are lots of satellite galaxies orbiting the Milky Way. There are 4 around us now which are of special interest: the Sagittarius Dwarf Galaxy, Canis Major Dwarf Galaxy, and the Large and Small Magellanic Clouds. Right now, the Milky Way is taking stars from all of the gas at least, but in some cases stars as well, from all of those galaxies. That's understandable now in our present day, but 11 billion years ago, when the Milky Way was only 1 billion years old, things were a lot closer together, but they also behaved differently.
Yes, absolutely. And it was much more likely early on, because as you said earlier, they were much more closer together. So a galaxy like Milky Way, when it was just forming, it would be surrounded by lots of gas clouds. You can see that the gas clouds will envelop not just Milky Way, but all the neighboring galaxy. And if there's a giant galaxy sitting in the center of those gas clouds, it will be sort of feeding off all those channels that are created by the gas and sometimes the gas clouds. So the process happens at a faster rate when the early on, because the density is so high and the things are not so far apart from each other.
Is that what you found? Is that the main result from this study?
Yes, absolutely. The thing is, when the gas or the stars are coming into a galaxy, they kind of increase the disorder in the gas that exists in the galaxy, and you can sort of use that amount of disorder to track down if the galaxy it acquired most of its stars by when the stars form inside itself, or the stars came from outside. Because if they have come from outside, it will have lots more disorder and lots of motions. And that's what we found, that these 11 billion year old galaxies, they had less amount of disorder compared to the galaxies which are sort of slightly younger. basically there's a transition that happens between when the galaxy forms. Early on, they acquire most of their stars from inside internal processes. That is, stars are going to form inside the galaxy. But later on, the galaxies, they are going to acquire most of their stars by feeding off the other galaxies, by feeding off the gas and the satellites that are surrounding itself. And they become giants.
What's the significance of these results in terms of our understanding of cosmology?
Quite a lot. Because this kind of process, this transition from, we call it in situ process, basically stars forming inside, to ex situ process, where growth happens from external processes like mergers, etc. This transition is predicted by the normal lambda CDM cosmology, that is, our universe is just full of dark matter and dark energy. But our study kind of pinpoints the exact epoch when this transition happened. We show that this transition happens between 10 to 11 billion years ago.
How was the research carried out?
So what we used the Mossfire spectrograph on a 10-meter telescope in Hawaii called Keck telescope, and it's one of the largest telescopes currently that we have, optical telescope. And on top of that, what we did was we used illustrious TNG simulations, which are giant cosmological simulations. They are running on some of the largest supercomputers in the world right now. And what happens is, because in astronomy, we can't really conduct any experiments because galaxies and the stars, they are so far away from us. So these simulations, we can kind of create a virtual universe via this simulation and test out, change some parameter, conduct small experiments to figure out how the galaxies are actually evolving, and test out what we think we know about how galaxies form is actually true or not.
Does it change our understanding of the Hubble tuning fork at all in the way galaxies form?
Actually, Hubble tuning fork kind of is misleading because it shows that galaxies earlier, they go from this nice spirally structure to elliptical and that kind of thing, right?
Yeah.
But that's not the case, because when you look at high redshift galaxies, like really, really young galaxies, they have more disorder, they have more random structures, and slowly those nice spiral structures kind of evolve. But in that process also, some of the galaxies, they are going to convert into elliptical galaxies, for example. If the galaxies live in really, really dense environment, it's going to interact with lots of its neighbors. It's going to undergo lots of interaction. And those interactions kind of destroy the nice spiral structures that is gas trying to build up. And instead of having a nice spirally disk, it will have an elliptical spheroidal envelope. So Hubble tuning fork, it's nice imagery, but that's not really how galaxies form. They go from blobs and random structures to these symmetrical spiral structures, kind of.
When you look back through Hubble Deep Field and Deep Field South, early galaxies look like train wrecks.
Yes and no. So that was the thing that we knew, that the galaxies, as you go far and far enough, they look like train wrecks, right? They have lots of turbulent motion. They have lots of random motions. The really young galaxy, they are blobby. They don't have any structure. But what I am finding is, when you go far enough, they are not as turbulent as we thought they would be. They are slightly less disordered than we thought they would be, and that's the fact that was surprising about what we are finding. Because till now, it's really hard to go really look at galaxies which are really far, because the signal that you are going to get from those galaxies is not enough. But now with these large telescopes, like the one I use, 10-meter telescope, you can still get an average sense of what's happening in this 11 billion years old galaxy. And we found that they have a quieter structure than their 10 billion year or 9 billion year old counterparts. So they are a bit more quieter. And that was the surprising part. And that's why we think that it takes a bit of time for this merger kind of scenario to kick in. Basically, it takes some time for the galaxy growth to happen via mergers or eating other galaxy. And that's when they will have a bit more organized or less disordered gas motions, basically. But we need larger telescope and ideally space-based telescope to really figure out this theory. Because right now in my research, I could get a single number for the average motion of gas. And you can imagine that for a Milky Way like galaxy, if you just have one number of average gas turbulence energy, that's not enough. And so what I'm really excited about is using the James Webb Telescope, which is supposed to be NASA's next space mission.
Next year, yeah.
Yeah, next year, hopefully.
Hopefully.
Yeah.
They've just done another test on the mirror, and the mirror is opening as it should, as it will in space. So
yeah, it is ready, but I think the COVID coronavirus situation again might delay the departure a little bit. And they still need to do some tests, which we are still holding our breath for those tests to be done.
Yeah.
Because they haven't still put together the whole system and then tested for the vibrations that the telescope is going to experience.
On the bumpy ride aboard the Ariane 5.
Yeah, it's going to be. And the whole unfolding process is going to be quite nerve-wracking as well. But hopefully, when it's up in the space, it's going to be fantastic, because the 11 billion year old or even younger galaxy than that, we really need a space mission to kind of resolve the structures that these galaxies have. From ground base, we can get a single number right now. We can get an average amount of gas these galaxies have. We can get an average amount of turbulent energy that these galaxies have. But with James Webb, we can resolve individual component and figure out whether the kinematics of the gas is what we think that from a single number.
Does the simulation show you why some spirals develop bars like the Milky Way has, a central bar?
Oh, that is a really good question. People are actually actively working on it still, and that is unclear because it really depends on the initial conditions of the galaxy.
Oh, yeah.
And you need to have really high resolution simulations to figure out, to disentangle different structures. So, for example, a bar is a very tiny structure in the whole scheme of a galaxy. And to distinguish the bar, like the Milky Way type bar, we need to distinguish it from another layer that our Milky Way has, which is the bulge. That is a lot of stars, like a high dispersion layer of stars. So you need high resolution simulation. The kind of simulation that I use, they don't currently have the sufficient resolution to make that distinction yet. But people are actively working on developing high resolution cosmological simulation, because you need those simulations to figure out what kind of initial condition you need to trigger the bar formation, for example.
That's Dr. Anshu Gupta from the University of New South Wales. And this is SpaceTime. I'm Stuart Gary. Still to come, a surprise visit from an asteroid no one expected. And later in the science report, China, Russia and Iran accused of cyber attacks targeting research on COVID-19 vaccines. All that and much more still to come on SpaceTime. Well, astronomers were in for a shock when an asteroid the size of a van suddenly swooped out of the darkness of space, streaking just 1,200 kilometres above satellites. The 8-metre-wide space rock, now named 2020 HS7, was detected by NASA's Hawaii-based PanSTARRS, Panchromatic Survey, Telescope and Rapid Response System. PanSTARRS discovered the asteroid just hours before its flyby, determining the object was already extremely close to Earth, with a roughly 10% probability of a collision. Observatories around the world quickly joined in efforts to find out more about this unknown asteroid. The Tautenberg Observatory in Germany, which frequently assists the European Space Agency's Near-Earth Objects Coordination Centre, monitored the space rock and quickly established it wasn't going to collide with Earth, but it was heading to an extremely close flyby. And subsequent observations from a network of telescopes around the world determined the flyby ranks among the 50 closest ever recorded. A very near thing. This is SpaceTime. Still to come, the science report. And China, Russia and Iran accused of engaging in cyber attacks targeting research on COVID-19 vaccines. And the first case of COVID-19 being detected in a family dog. All that and more still to come on SpaceTime. And time now to take a brief look at some of the other stories making news in science this week with the Science Report. China, Russia and Iran have all been named as being engaged in malicious state-sponsored cyber attacks targeting British universities and research centres working on vaccines to fight the COVID-19 coronavirus. The three rogue nations were identified following earlier reports from Britain's National Cybersecurity Centre that state-sponsored attacks have taken place. While these cyber attacks have not yet been successful, the agency has urged universities and research centres to upgrade their online security immediately. You may recall that last year, China was identified as being behind a series of identical attacks focusing on Australian universities and research centres. News of the new attacks follows warnings by the FBI that criminals have been hacking into health and medical research centres and releasing new versions of ransomware. The US Food and Drug Administration has authorized the use of the experimental COVID-19 drug remdesivir for emergency use in patients. The emergency authorization doesn't mean the drug has FDA approval. That can only come after detailed human trials. But the FDA can issue emergency authorization for unapproved medical products that may help treat life-threatening diseases when no approved alternatives are available. It follows an announcement by the US National Institute of Health of preliminary trial results showing that advanced COVID-19 patients who received remdesivir recovered faster than similar patients who received a placebo. But the results from this randomized controlled trial involving 1,063 patients were in contrast to a separate smaller Chinese trial which claimed to show no clinical benefit for remdesivir in COVID-19 treatment. Well, last month it was a cat. Now the first case of COVID-19 has been detected in a family dog. It seems a 2-year-old pug named Winston who lives in North Carolina has tested positive to the virus. Scientists from Duke University made the discovery while testing Winston's family, all of whom have had the virus. Researchers say Winston's symptoms lasted for just a few days and were relatively mild, with some sneezing, heavy breathing, and being a bit sluggish. But most telling of all was that Winston didn't finish his breakfast one morning. Scientists say there's no evidence that pets can transmit the virus to people. The family's other 2 pets, a 12-year-old pug named Otis and Mr. Nibs, a 12-year-old tabby cat, have both tested negative. And as for Winston, well, the good news is he's made a full recovery. A new fossil suggests that the monster dinosaur Spinosaurus was far more at home in water than on land. Forget what you saw in the movies. Spinosaurus's elongated body and relatively short legs always meant that it had a design which was far more like a crocodile than a T-Rex. Now, paleontologists at a dig site in the Sahara have uncovered the remains of a spinosaur with a powerful fin-like tail, making it potentially quite unique among dinosaurs. The findings, reported in the journal Nature, follows decades of debate on how much of Spinosaurus's life would have been spent in the water and how reliant they may have been on aquatic prey. The United Kingdom's Professional Standards Authority has placed a ban on the homeopathy industry's so-called complete elimination of autistic spectrum expression, or CEASE therapy, because the scientific testing has confirmed that chunky and doesn't work. CEASE is just one of a long list of pseudoscientific treatments being pushed by homeopaths, which medical experts have found have no scientifically proven benefits. Tim Mendham from Australian Skeptics says, while it's an appropriate move by the Professional Standards Authority, any prohibition is meaningless unless it's adhered to and disciplinary action taken against those who ignore it.
There's an organisation in the UK called the Good Thinking Society, which was set up by a Dr. Simon Singh, who's a well-known author and a campaigner against chiropractic in some cases. But also, this was set up to actually look at medical issues and to see sort of those areas which have no validity. And one of the big areas that the Good Thinking Society has been looking at is homeopathy. The problem was that the UK Professional Standards Authority, which is the one that looks at medical practitioners and medical practices and signs off on them or not, approve or recognise the homeopathy industry. This was sort of last year. But they come for regular renewals of their licence, if you like, or their authorisation under the PSA. And homeopathy came up and they got the tick to go, it continued to go ahead. The Good Thinking was pretty upset about this and put a challenge to that decision. And since then, the PSA has put a few caveats on its decision it made to support homeopathy. And one of the areas that it has placed a ban on is a treatment called, or a therapy called, complete elimination of autistic spectrum expression. CEASE, so it looks like one of those organisations where they had the acronym and then tried to make the words to fit. But of course, homeopathy, often largely anti-vaccination spreads a conspiracy that autism is caused by vaccination. So homeopathy creating a market for itself. Homeopathy doesn't work, to say the least. And after the Good Thinking Society put in their sort of complaints, etc., the PSA brought down this judgment that they can't teach this anymore. That means that Good Thinking has sort of now withdrawn its case of legal action but it's now obviously has to keep close watch on the homeopaths to make sure that they're not still offering this therapy, which is a shonky therapy.
That's Tim Mendham from Australian Skeptics. And that's the show for now. SpaceTime is broadcast on Science Zone Radio by the National Science Foundation in Washington, D.C., and through both iHeartRadio and on TuneIn Radio. Or you can subscribe and download SpaceTime as a free podcast through Apple, Stitcher, Bytes.com, Pocket Casts, SoundCloud, Spotify, YouTube, Audio Boom, Podbeam, Android, Castbox, from spacetimewithstuartgary.com, or from your favorite download podcast provider. You can help support the show and the work we do by visiting the SpaceTime online shop and grabbing yourself a few goodies, or by becoming a SpaceTime patron, which gives you access to commercial-free double-episode versions of the show, as well as bonus audio content and other rewards. Just go to our Patreon page through spacetimewithstuartgary.com for all the details. If you want more SpaceTime, check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as loads of images, news stories, videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word and in lowercase, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, at SpaceTime with Stuart Gary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to www.facebook.com/SpaceTime with Stuart Gary. SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.